companies that was very early to cloud. Okay. And this should give you forward and back. Yeah, there you go. There you go. Awesome. And also just like to say that Randy has a great blog that I enjoy reading where he talks about cloud computing specifically around infrastructure as a service most of the time, but not necessarily in a lot of detail. And so if you really do enjoy reading blogs where someone gets really down into, I think, some of the deep core issues around cloud computing, I would recommend following his blog.
Thanks. Hi, how are you doing? So just to follow up on that real quick and plug it a little bit further, one of the things that's distinctly different about Cloudscaling from probably most of the other startups is that we started as a professional services business and then pivoted over to become a product business. And that professional services business was working on building large-scale infrastructure clouds for people like Korea Telecom, Internet, and U.S. carrier I can't mention. And so part of what that means is that the product is basically an embodiment of how we think about building systems. We didn't create something that was predictive based on how we think the market's going to break. We didn't bring to market, some products that we already have that we want to call cloud now. We're not in the act of cloud washing. This is actually a product that's based off of our experiences building systems. How many people have used Amazon Web Services? Okay, great. All right, so when I've been working around the globe and talking to folks, both people we deployed systems for, people we talked to about deploying systems for, but didn't actually work with them, the thing that I noticed, since the very beginning of sort of, engaging with these folks, both through the blog, Twitter, and our own customers, is that there's a fundamental difference between what's happening on Amazon and what's happening, sort of what I think of as enterprise clouds, either behind the firewall or through some of these public providers. And so when you look at Amazon, look what's been driving their growth, which has been, tremendous. It's 100% year over year. The speculation is it's roughly $1 billion a year business now after 5 years' time. So that's an incredible growth rate. I mean, you don't see it that very often. And what's interesting is the vast majority of those applications are different. They're mobile, they're web, they're big data. And the one characteristic that's common across all of those applications is the need for scale. Whether it's a small startup that's trying to get a lot of leverage so that they can operate like a large enterprise and have the same kind of compute resources, or whether it's an individual or a team within an enterprise that's trying to go outside and be more successful, the big difference is scale and sort of ease of use, that sort of on-demand notion. And so what we've noticed is that there's sort of a sea change occurring. And that sea change is that there's, both the internet but other very large platforms like Facebook, iOS, Android, and sort of the evolution of ever-increasing amounts of data has sort of changed the way that people are building applications. So today, inside of sort of the enterprise data center, you've got sort of those traditional applications. And sort of the early 90s, that was a large application, say SAP for 100,000 employees at General Electric. That was a big app. But nowadays, that's a very, very small app. Something like Facebook shows us that apps need to get to be to hundreds of millions of users in size. And that's fundamentally changed the game. A lot of the new go-forward applications, like Netflix being a canonical example of that, have fundamentally different needs, and they need fundamentally different infrastructure. And part of that is because if you plug into some of these super platforms, you plug into Facebook or you develop a new iOS application inside the enterprise and you deploy it, you can go from 0 users to tens of millions to hundreds of millions of users pretty much overnight. And most enterprise IT infrastructure can handle that. So what we're seeing is that the applications themselves, these new cloud-ready applications, are actually driving change in the underlying infrastructure. If you look at how Google is designed, I don't know how many have looked at Google, but Google's a big layer cake. There's their commodity hardware and their custom data centers. Then there's Google FS. Then you have Bigtable, which is a columnar database. And then you have MapReduce on top of this. And then on top of that, you have each of their applications, Search, Mail, Google Apps, Google App Engine. And essentially, they use that same layer cake. And it's a very, very different design than what exists in the enterprise data center. It's about automation. It's about scale out. It's about serving millions of users and not tens of thousands. And so we see that as sort of where things are heading. So the problem is that only these large internet operators have this infrastructure model to support these kind of cloud-ready applications. And so what we're trying to do is make sure that everybody can have this. And the hard part is not how do you take a virtual machine image and put it on a hypervisor. My team prototyped that in 3 days, 3 guys in 3 days, and that's trivial. That's mouse nuts. It really doesn't matter. When you look at how Amazon Web Services, how Facebook, how Twitter, how Google are all designed internally, from the data center, the concrete, all the way up through the applications, it's a completely different design. And so what we see is the need to actually bring that design so that other people can have it. And there are elements of this today. We see that in the Open Compute project that Cole mentioned, where Facebook is allowing people to see sort of their hardware designs for these next generation data centers. And there's a lot more happening. When you the way I sort of think about this is that somebody like Google has figured out how to do something differently, and you see a lot of open source projects where people are trying to take that capability and bring it to everybody. So for example, Hadoop. People are familiar with Hadoop. Hadoop is Google's MapReduce, clean room. Cassandra. Cassandra is Google's Bigtable, clean room rewrite, right? So you see a lot of people trying to adopt these new emerging models, and the problem is that there's not a holistic, sort of system-style approach to actually delivering next-generation infrastructure to support these cloud-ready applications that people can go out and get today. There are pieces, like there are pieces in OpenStack, but there's not the entire story, and that's what we're trying to do. And so we call that open cloud, where we're really combining the elements of openness, which I'll talk about here in a second, with the scalability of cloud. And so for me, just to be really clear, because sometimes people get confused, when I talk about cloud computing, or I guess I'll just flip back here, when I talk about sort of the enterprise model versus the emerging model or the cloud IT model, I really think about a very different approach. So most people, when they say I'm building a cloud, what they think is they're getting virtual machines on demand. That's not a cloud to me, right? That's virtual machines on demand. And so some people build a cloud for the enterprise model, which they call an enterprise cloud, which is fine. And some people build it in the next generation model. And this is what I think of as a cloud, and that's not what I think of as a cloud. So when I say open and cloud, I mean an open system designed for high-scale, next-generation cloud-ready apps. So I don't want to take up too much of my time. So I'm going to skip through some of this. So open cloud, what it means is really 4 key things. And we try to boil this down and make it simple to consume. It's open APIs and protocols, open hardware, open networking, and open source software that brings it together. Now, see, this is a very different approach when you think about it to some of the other infrastructure as a service vendors who are simply providing really the software. So open APIs and open protocols, I think everybody knows or has some sense of what that is. But by open hardware, I mean things like the Facebook Open Compute project, where the actual hardware blueprints, the specifications, the rack layouts, and all of these things are actually open sourced and are owned and operated by the community. But I also mean that it's open hardware in that the hardware itself provides no lock-in. It's commodity x86 servers that you can use, and you can transplant one x86 server with another. So the difference is, for example, when we were at Korea Telecom and implementing their infrastructure as a service cloud, and we were using HP systems, we had a lot of problems with the ILO because the ILO wasn't standard. Whereas all commodity gear uses IPMI, which is a standard protocol. So by open hardware, I mean servers that actually provide no lock-in. By open networking, I mean open source blueprints. I mean software-defined networking or network virtualization, which I don't have time to talk about today. And I mean some of these emerging, more open networking platforms. So if we look at, for example, Arista allows you to install software or even run a virtual machine inside the switch, which is something you couldn't do for the legacy enterprise vendor switching gear. And then open source software, I think everybody has a sense of that. So am I going too fast? All right. So our focus is on large-scale systems that are production grade, and that's really what we're about. And to deliver that, we're going to provide something called the Open Cloud System, and then that's delivered in conjunction with a set of services called CloudPath, so we can help customers get it to market. Not only is it scalable and designed for production grade and focused on these next generation applications, but from our perspective, it aims to provide 100% compatibility with Amazon Web Services. Now, I don't mean that the APIs are compatible. I mean the system is compatible. I mean the architecture is compatible, the network's compatible, the storage is compatible, and the virtual machine instance sizes fit the exact same performance profile of those in Amazon Web Services. Later, we'll be supporting Rackspace Public Cloud. So there's three pieces to the Open Cloud system. The first is the software, which is the Open Cloud OS, which is our distribution of OpenStack. The second is hardware blueprints, which are designed for particular workloads. And then the third is what we call the CloudBlocks architecture, which allows us to marry the software with the hardware in a meaningful way so that we can mimic or replicate a very specific system like Amazon Web Services or Rackspace Public Cloud. Sorry, I should have got some water before I came up here. So the Open Cloud operating system basically has three key pieces. At the top, end users access the system via APIs where they can request a resource, just like any other infrastructure as a service, that comes out of a multi-tenant resource pool, and that resource is allocated to them. Oh, I like you. I owe you a beer. Excuse me. Second, the way the system is designed is that it has an opinion, and that opinion is expressed in topology. So there's a scale-out networking model, along with a way to organize things in regions and zones, and what we call subzones, which are hidden from the end user. And then in some cases, you can actually partition part of that cloud so it's only used by a single tenant, which is very similar to Amazon Web Services dedicated instances capability. And then the final part of the Open Cloud OS is the hardware lifecycle management piece, which provides provisioning, burn-in, and verification. And this is one of those things where you see people who've not run a large production system who become very confused. There are some videos which I won't call any names, but there are videos showing standing up a cloud in 5 minutes. At Korea Telecom in 2010, we got in about 10 racks of gear in one of the data centers, and we stood them up, and we had systemic drive failures across the entire 10 racks. What was the problem? We don't know. But we had to do hardware burn-in to actually figure out that it was a bunch of DOA drives. Drives appear DOA. You will never turn on a cloud in 5 minutes because most disk drives either fail in the first 48 hours of operation of being exercised or fail 3 to 5 years later. So production-grade systems know this, and they actually exercise and burn in the hardware for the first 48 hours or possibly even 5 days, depending on how long you want to make it, 2 to 5 days. And in doing that, determine that the hardware is really ready to go in production. So we've thought ahead about that kind of thing, and you won't see that thinking in any of these other systems, which are mostly just software. So we wrap OpenStack into Open Cloud OS, and we add a bunch of capabilities. And again, it's a very opinionated approach, right? You're going to get Amazon. And so there's a topology model, and there's what we call the Open Cloud Data model, which allows us to mimic that hierarchical structure that Amazon has of regions and zones and virtual machines and these kinds of things. We added a bunch of capabilities around operations, so security and logging, metrics and logging, and security hardening, and then, of course, the provisioning, and then the scale-out networking model, which I don't have enough time to talk about tonight, but the scale-out networking model works in conjunction with the CloudBlocks architecture so that you can build a system that's 1 rack, and you can scale that to 100 racks, or you can scale that to 1,000 racks.
And Randy?
Yeah, 1 minute. I was told I had 15 minutes tonight, just to be fair. So the CloudBlocks architecture basically allows you to take a piece of Open Cloud OS and design to run on a specific hardware blueprint that's designed for that workload. So for example, Swift object storage nodes can be coupled with hardware blueprints that are designed for that software. And so that's what the CloudBlocks architecture is in sort of a nutshell. There's a lot more details there. And so you've got a set of block designs, which are the software that then get married to the hardware, which become a block instance. You can think of it as almost a one-to-one mapping between racks. A rack is a block. Hardware blueprints, and the best way to think about this is, I'm saying you can take any hardware you want. We have a very tight specification that says that hardware has to be this processor type. It has to have this ratio of disk to RAM to CPU. There's got to be this many in a rack. They have to be cabled to the switch at the top in this way. And that if you do that and you use our software, you will get Amazon EC2 instance sizes of M1.small, M1.large, or M1.extra large that have the exact same performance profile as Amazon Web Services. Or we can give you a hardware blueprint that would give you CC1.cluster, CG1.cluster, or whatever particular Amazon Web Service instance types that you're looking to have. And then finally, our services. You don't care about this. No, I don't care about this anyway. We help you get it to market. So that's probably my minute. There's a lot more on the website. I have to leave after this, unfortunately. I have a previous engagement. So if you want to follow up with me on Twitter or email, I'd be happy to field any questions you have. We're also hiring pretty aggressively. And, if you haven't read the blog, please do so. Cheers.
Great. Thank you very much. Thank you.